Introduce myself. My name is Dada Mohammed Abdurrahman. I work as a petroleum engineer for Insalah Gas, which is part of a joint venture between Sonatrach, ENI, and Equinor. In this short period of time, we will see how machine learning can be leveraged in order to improve the overall performance of oil and gas exploration and production activities. This presentation is structured as follows. We will start by an introduction, then we will see what machine learning is about. After that, we will see what kind of research initiatives have been undertaken by petroleum practitioners in order to solve problems related to exploration and production. Then we'll see what kind of machine learning based solutions have been implemented as part of industrial projects. And at the end, we'll finish by a conclusion. Let's get started. In a highly competitive environment, innovation has always been the key for oil and gas or any company to address market demands, generate revenue, and maintain a high level of competitivity and leadership. Industrial operators, especially those dealing with oil and gas, have adopted machine learning solutions because of their considerable potential in solving a lot of and interrelated complex problems, as well as the way they deliver insights to decision makers in a short period of time, let's say quickly, and with a high level of accuracy. This has been made possible thanks to the massive amount of data accumulated over time, the rise and the development of data transfer systems such as Internet and the Ethernet. Also, we have an ever-growing high computing systems, as well as we have also a lot of cloud solutions that allow us to perform calculations through the Internet online. And we have also big data solutions that are available to any practitioner in order to handle large data sets. A lot of experts have the vision that machine learning will play a pivotal role in shaping the future of the fossil fuels energy sector and driving significant progress within the E&P activities. For instance, according to McKinsey & Company, machine learning and big data applications could help the hydrocarbon industry save up to $50 billion in the next decades. This money will help operators initiate research, do additional investments, and a lot of things. Others said that if the hydrocarbon industry succeeds in applying machine learning techniques in its E&P disciplines, the savings in terms of time and associated costs will be significant. The choice made by oil and gas companies such as Gazprom, ExxonMobil, Equinor, Total is wise and deserves to be considered for potential development of machine learning based solutions to the oil and gas problems. Instead of venturing alone into this highly technical domain, they have opted to collaborate with high-tech companies such as Microsoft, Google, and NVIDIA. This collaboration has led to outstanding results, and a lot of expertise have been gained by the engineers and researchers as a consequence. The main goal of this presentation is to show to the Sonatrach managers and engineers, I hope there are some here, is to show them what kind of problems can be solved in machine learning, and what's the best way forward to implement machine learning as part of industrial projects. So what's machine learning? Machine learning is another way of solving problems using data without a priori knowledge of the physics of the logic behind the problem. It relies on some concepts of statistics to extract knowledge and derive meaningful insights, and it can be used to understand or investigate particular phenomenon. It has been also used in some circumstances where analytical or numerical model cannot be used to solve a particular problem. Machine learning is subdivided into three categories. The most known one is supervised learning. In supervised learning, we try to find the correlation between inputs and outputs. Supervised learning is used to generate predictive models. We can build regression models or classification models. The second category is called unsupervised learning. In unsupervised learning, we try to perform a thorough exploratory data analysis to unveil hidden patterns between data. In order to spot clusters, we can do clustering in here. Unsupervised learning can also be used to perform dimensionality reduction. In some problems, we may end up dealing with 20, 50, or 100 of variables. It will not be practical to solve problems using a lot of variables. And dimensionality reduction techniques allow us to reduce the number of features, let's say to 20 or 15, by preserving the information that is encapsulated into a particular dataset. The third category is called reinforcement learning. Reinforcement learning is all about doing optimization. Here, a learning algorithm tries to find the best solution or optimal solution to a particular problem. It relies on the concept of trial and error to maximize the objective function. It was first developed for autonomous systems and robotics. It has been applied to oil and gas E&P problems in the topics of field development planning, fluid flow migration in the subsurface, as well as assisted history matching. Machine learning solutions are solely implemented using programming languages such as Python, R, C++, or MATLAB. Codes can be implemented on premises, it's using internal capabilities, or through the cloud using solutions provided by, let's say, Amazon, AWS, Microsoft, Azure, or Google Cloud. Having said that, let's now move on to see what kind of research have been implemented to solve particular topics related to the E&P sector. With regards to geosciences, we all know that feedback from geoscientists is crucial to perform a quality assessment of the prospect under investigation. The feedback from geophysics is also crucial, as they allow us to have a first picture of the reservoir, how layers are structured, how faults are structured as well into the reservoir, as well as they can tell us where possible or potential hydrocarbon traps are located. Geophysicists may end up dealing with seismic data or seismic images having missing or blurred traces, and here come the importance of using a particular type of neural networks called generative adversarial networks to perform image reconstruction. It's also noteworthy to mention that GANs have also been applied to perform assisted seismic inversion in order to derive critical parameters of the reservoir, such as rock properties, fluid contents, porosity, and permeability. GANs have been developed by Ian Goodfellow, who was head of research at Apple and Facebook. GANs have been designed to create stunning and synthetic images or data often indistinguishable from initial ones or real ones. To put it simply, GANs are composed of a generator and a discriminator that works in parallel. A generator creates images from scratch, then try to refine them to produce at the end realistic or images, while a discriminator works as classifier and tries to distinguish between realistic images and fake images that do not replicate the attributes of the initial or raw images. Here's an example of using GANs to perform images reconstruction. The authors here deliberately eliminate some parts of images. They train the model after testing it and validating it. They perform predictions using two approaches. The first approach is using one simple GAN, as shown here in image C, while the second approach was implemented using a series of GANs. And look here how these two images are looking to the initial one that is shown in here. The resemblance is absolutely remarkable. Another type of neural networks, by the way, neural networks are advanced algorithms of machine learning, but they are classified as deep learning algorithms. So, as I said, conventional neural networks have been used to perform other duties related to reservoir characterization, such as cell bodies and seismic fault detection. CNNs allow to delineate image contours or objects within an image. They can be used to build regression models and classification models. It's noteworthy here to mention that it will be interesting to check the works done by Ruslan Miftakov from Geoplat AI on how to use neural networks to perform geoscience duties, such as salt bodies delineation, seismic fault detection, as well as seismic image reconstruction. Using CNNs, we can create regression models, it is to say, doing image-to-image translation, or that are under the models that are used to do this task are known as peaks-to-peaks models. They allow to predict images for images. An example of this is shown here to the right. Here, so we can predict salt domes from seismic images. In the top here, this task has been done manually or using conventional methods, while here in the middle, a simple machine learning algorithm called sparse vector machines, or SVMs, have been used, but the result was not totally good. What you see here at the bottom is using CNN to perform to delineate salt domes, or to predict salt domes from seismic images, and look here for how the output is nearly the same as when using conventional methods. Another example of using peaks-to-peaks models is predicting dips or sinusoids from subsurface images or from resistivity logging images. This kind of problem has been proposed by Schlumberger 2 years ago as part of a challenge that was hosted or organized by a platform called Challenge Data, and the goal was to predict sinusoids from resistivity logging images. We can also use CNNs to build classification model in order to determine or locate faults. An example is shown in here. So here the authors perform two approaches. The first approach is by using conventional or classical models to perform fault interpretation, while here what you see here and below is by using CNNs. And look here for the difference between the two methods. The image shown here at the bottom is the level of the accuracy of the image shown here at the bottom is incomparable with the one shown here by image C. Moving on with the reservoir characterization. So here, simple machine learning algorithms such as SVMs, decision trees, or Random forests were used to predict lithospheres or petrophysical reservoir properties such as water saturation, porosity, permeability, from logging data structured or organized in tabulated formats. These machine learning algorithms tend to outperform conventional analytical models usually applied to perform these two tasks, and it's not so complicated to implement them using Python in comparison to neural networks. The same approach was followed with regards to drilling and completion activities in order to anticipate unwanted events and minimize MPT. It will be good to check the paper cited in here to check how it's possible to reduce MPT and save a lot of money by simply building prediction models based on the analysis of drilling parameters and the trends of the critical equipment involved during the process of completion and drilling. Usually here, time series datasets are used to generate predictive models, and we can easily detect or anticipate unwanted events, whether they are located on surface or downhole. It's also noteworthy to mention here that the job made by Zhang and al. Is a new approach in order to detect any anomaly. So here the authors relied on the capabilities of NLP. It is say natural language processing, in order to prevent the occurrence of any unwanted events. So here they collected a lot of drilling and completion reports. They digested them using NLP techniques, and at the end they were able to spot whether a problem is going to occur or not based on daily reports that they receive on a day-to-day basis. With regards to reservoir engineering, so deep learning algorithms have also been applied to perform field development planning tasks as well as reservoir simulation. Here, I would like to highlight that a new type of neural network called physics-informed neural networks have been applied to simulate performance of CO2 injection and post-CO2 injection. Pins have been designed in such a way to mimic derivatives that we usually encounter in partial differential equations. The authors here performed a comparison by using a conventional simulator called GEM that is developed by CMG, and by using pins. Pins can be really faster, 250 times faster than conventional simulators. Here for the same results, we can perform duties of reservoir simulation in a more quicker way. So here let's check here the results. The outputs are really the same when using CMG, and the level of error is extremely low. So it's a good alternative. Pins are a good alternative to any conventional reservoir simulator. Let's now move on to see what kind of industrial projects have been implemented with the oil and gas companies. So the first example is a collaboration between Baker Hughes and NVIDIA. This partnership aims to harness specific databases and introduce machine learning to oil and gas companies for an efficient utilization of their datasets. Seismic data, drilling reports, values, logs, and production data have been harnessed in order to give insights and help managers in their decision-making process. In terms of production, two companies claim to have developed a deep learning-based application that is capable of predicting anomaly detection with a high level of accuracy in comparison to classical models. So there, the model developed by NVIDIA and Baker Hughes is 3 to 5 times accurate in predicting or in detecting any anomaly, as well as it is 4 to 5 times accurate to predict when an equipment is going to fail or malfunction. The second example is a partnership between Total and Google Cloud. So this collaboration aims to develop an AI-based system for the analysis of data exploration data. The objective is to allow engineers to perform their duties in a more efficient way. To this date, the two companies have not reported any result or any lesson learned from this project, but they say that the model that they are going to develop is based on computer vision technology, which involves advanced neural networks, CNNs, in order to perform image analysis, image segmentation, in order to derive critical insights or information. Third and last example is a partnership between Equinor and Ambient. So this partnership, in 2017, Equinor acquired Ambient's AI solution called Infinity with the goal of improving oil production from its oil wells located in the Bakken Formation. This AI-driven solution is a key component of Equinor's digitalization strategy, providing real-time monitoring of equipment and facilities through the IIoT, let's say Industrial Internet of Things. So these solutions comes as part of a digitalization project or a digitalization strategy. Here we have a lot of sensors mounted on different critical equipment, as well as mounted onto wells. Yes. These IoT allow to transfer data to Infinity platform, and the AI solution, the Infinity AI solution, will perform a series of scenarios in order to come up with the best solutions at each time. It has been reported that Equinor has achieved 6% increase using MBS technology in overall oil production, as well as wells suffering from overpumping. So have been the overpumping has been decreased by 11%. To sum up, the oil and gas industry, known for its demanding and competitive nature, has always hinged on innovation for petroleum companies to address market needs, optimize costs, and generate revenue. Technology and innovation have historically been pivotal for the growth of oil and gas industry, and machine learning is emerging as a promising and innovative tool to meet the oil and gas or petroleum companies meet various targets and solve complex problems. The Sonatrach can fully take advantage of the multiple lessons learned from existing industrial projects and research done in the field of applied machine learning for its own E&P activities. Machine learning-based solutions will definitely help Sonatrach achieve its targets. For this to happen, an efficient strategy needs to be set in order to take advantage of the capabilities offered by machine learning technology. The following have to be taken into consideration to take the most from machine learning. We need to establish partnerships with high-tech companies that are specialized in machine learning, big data, and AI solutions. We need also to move forward with the digitalization of all. The Sonatrach needs to move forward with the digitalization of its activities. By the way, during this year, Sonatrach has concluded a contract with the Chinese Huawei in order to perform a lot of digitalization projects. That's a good point and a good start. It's a good starting point for implementing machine learning and AI solutions. And also we need to train our engineers and practitioners to get strong foundation in machine learning techniques, because it's not so easy to step into the field of machine learning. You need a lot of expertise, a lot of here. So partnership is pivotal to get the most of machine learning. We need also to build the machine learning teams, and we need Sonatrach needs also to hire AI engineers coming from the university to strengthen teams that will be part of a digitalization strategy. That's all for this presentation, and hope it was interesting. Thanks for attending, everyone.